Welcome to another physics class. Today, as I promised in our last lesson, we are going to look at Newton's laws of motion. Newton's laws of motion. And the first one we are going to look at is Newton's first law of motion. And when you say Newton's first law of motion, it states that every object will continue in a state of rest, or if for motion, it will continue with uniform velocity or speed unless being acted upon by an external force. Again, when you say Newton's first law of motion, it states that every object will continue in a state of rest, or if for motion, it will continue with uniform or constant speed or velocity on a straight line unless it's being acted upon by an external force. Let's try it. Newton's first law states that every object will continue in its state of rest or motion with uniform velocity or speed in a straight line unless it is acted upon by an external force. The external force there can be unbalanced force. So this is the Newton's first law of motion. So to illustrate this with various illustrations, let's look at it. As we can see on the screen, look at the first ball. The ball is at rest, and according to the statement, the ball as an object will remain at rest unless it be acted upon by an external force. But if there is no external force out on it, it will remain there at rest. Second ball, the ball is on motion. According to the statement, this ball as an object will remain on its motion with uniform speed of velocity in a straight line. If there is no unbalanced force or external force out on it, the ball will continue like that. That is what this Newton's first law is trying to put forward. Let's use another illustration as shown on the screen. Look at the ball again. The ball is at rest, but this footballer now serves as an unbalanced force or external force. When the ball is kicked, the ball moves to air in uniform motion. But as the ball is moving continuously with uniform speed, then the ball reaches a net, and the net now stops the ball finally. So the net again serves as an unbalanced force which stops the motion of the ball. That is what the law is trying to put forward. Unless if there is no external force out on it, as at rest from the original position, it will remain at rest. Let's say the footballer kick it, then it should be on motion. It will remain on motion. As the footballer kick the ball is on motion. Again, the ball enters the net. The net also now serves as unbalanced force, which stops the ball from it being on motion finally. Also, the net also now serves as unbalanced force. Now, the next thing is various examples of Newton's first law of motion. In any exam question, you may be asked to state or mention examples of Newton's first law of motion. So let's look at the example now. Mind you, in the example, we are going to look at object at rest at the same time object or motion. Once the statement on the Newton's first law is based on object at rest, will remain at rest, and object or motion will continue with uniform motion on a straight line. Then all the examples we are going to look at now will be based on that 2 points. Now the first one we are going to look at is this car at a stopping light. When the car reaches a traffic light, then they need to stop. Then the car will be at rest. Look at the second example here, a swinging pendulum. This is on motion, to and fro. This one now has already shown on the screen. Look at this third example now, and eye staking. This one also is on motion. It's a typical example of Newton's law of motion. Look at the next one, space traveling. It's on motion. It's another example of Newton's first law of motion. Look at the next one, a soccer ball at rest. The ball is at rest. Once it's at rest, it's a typical example of Newton's law of motion. Then the next one is a roller coaster. The roller coaster is on motion. So it's a typical example of Newton's laws of motion. That is Newton's first law of motion. Look at other examples as shown on the screen. The next example now is door stopper. That's door stopper at rest. So it's examples of Newton's first law of motion. Next is jumping. Jumping is typical examples of Newton's first law of motion. That is, the jumping is a vertical motion. Another one is opening a bus. When you open a bus, that's examples of Newton's first law of motion. The next one here is stopping a moving shopping cart. The cart is already in motion. When it's being stopped suddenly by this person, it's a typical example of Newton's first law of motion. Then hockey at rest is another example. Pushing a long mower is another example of Newton's first law of motion. The further example on the screen, that is, don't forget we are looking at examples of Newton's first law of motion. Next is swivel chair, that is at rolling. It is typical examples of Newton's first law of motion. Stopping a swing, that is a side swing. Stopping a side swing is another example of Newton's first law of motion. Then this is a sliding on the screen, as shown on the screen. Is another example of Newton's law of motion. Then unsecure item in a moving car is another example of Newton's first law of motion. A ball rolling on a slant shape is another example of Newton's first law of motion. Pushing a stroller is a typical example of Newton's first law of motion. To mention but few, now in any question, if you had to state or mention examples of Newton's first law of motion, don't forget to mention any object at rest or any object or motion or uniform motion which will be on a straight line. Another example as shown on the screen. When you look at it, you can make mention of each example in any exam question. Quote them as examples of Newton's first law of motion. Next is Newton's first law as applied to various objects. The first one we are going to look at is how Newton's first law can be applied to falling objects. If you are looking at it on the screen, this is falling object from certain height. When the object is at rest, the weight we act on it and the air speed will be equal to 0. At the same time, when the air speed is equal to 0, no drag at all. But when the object is released from this height, since the air speed the drag depends on the airspeed. The airspeed increases, therefore the object accelerates. As I said, the drag is depend on the airspeed. When the airspeed is increases, so also the drag also will increase. And when the drag increase, there will be a point when the drag will be equal to the weight of the object. When this occurs, the object will no longer accelerate, but it will hold a constant velocity. When it holds at this constant velocity, when the object is no longer accelerate, this constant velocity is called terminal velocity. That is the velocity at which the falling object will no longer accelerate at the particular point when the drag is equal to the weight of the object. That is how Newton's first law is being applied to a falling object. And don't forget our statement that every object will remain at rest when it is at rest or continue with uniform motion in a straight line unless being acted upon by an external force. Now, the next we are going to look at is how Newton's first law can be applied to a rocket. How Newton's first law can be applied to a rocket lift off. Now let's look at it from the screen. This is the figure of the diagram of the rocket. The thrust will be below. The weight of the rocket will act downward. The net force also will act upward. Mind you now, as the rocket is at rest, state of rest, the airspeed will be equal to 0, as we explained under falling object. But look at the differences now. Under the falling object, we talk about the drag. Here now is thrust that will lift up the rocket. Now, as the thrust is increasing from 0, now the weight decreases slightly as the fuel burns. Because when the fuel burns, it will decreases the weight. So when there is decrease in weight, there will be a particular point when the thrust is greater than weight. When this occurs, the net force, that is when the thrust is greater than the weight of this rocket, the net thrust will be positive. The net force will be positive, which will push up the rocket upward. And when this one occurs, the rocket will accelerate upward and the velocity will increase. If velocity increase, then the rocket will move upward. That is how the Newton's first law of motion is applied to a rocket lift up. Now, let's look at how the Newton's first law of motion is applied to a kite. Look at it from the screen. The weight of the kite will act downward. The lift will act upward. Then there will be a vertical pull downward, which also will act downward. Again, there will be vertical velocity, which will allow the kite to move upward. Now, initially, the kite is in stable flight. At this particular stage, the vertical velocity when the kite is at the stable flight will be equal to 0. That is, when the kite is at stable flight, the vertical velocity will be equal to 0. Build the balance force, then the weight and the vertical pull will be the unbalanced force that we had on the on the kite. Now, when the wind, that is when the wind blow now, the wind is increases, then the lift as we can see, the lift depends on the wind speed. So when the wind increases now, lift also increases. And when the lift increases, the unbalanced force on the kite also will climb up and we move up the positively with vertical velocity. So the kite will move up with its vertical velocity. This is how the Newton's first law of motion will apply to kite. And don't forget our statement that every object will continue or persist in a state of rest or uniform motion in a straight line unless being acted upon or being compelled to change by an external force. Now, let's look at how Newton's first law is applied to airplanes. That is, airplane must be at a certain altitude. That is, must be fly at a certain or constant altitude. So at this particular point, the thrust and the drag are equal. So the aircraft hold a constant air speed as shown on the screen. Look at it, thrust and the drag in opposite direction, but the air speed in the direction of the thrust. So if the thrust is increased, definitely the aircraft accelerates because the speed of the aircraft now it depends on the airspeed. So when the aircraft accelerates, then the airspeed also increases. And as we said the other time, the drag depends on the airspeed. So once the airspeed is increases, then the drag also will increase. So when this occurs, the drag is equal to the thrust. And when the drag is equal to the thrust, then the aircraft is no longer accelerate. Take it again. When the drag is equal to the thrust, the aircraft is no longer accelerate, but hold a new higher constant air speed. That is, the aircraft now will now move with higher air speed, but it will no longer accelerate. That is how Newton's first law of motion is applied to aircraft or airplane. Don't forget the statement we are trying to explain under this Newton's first law of motion, that if object is at rest, it will remain at rest unless an external force acts on it. But if it is on motion, it will continue in its motion in a uniform speed or velocity in a straight line unless the external force acts on it. If you can now remember what we have done under inertial mass now, you can now say that this statement is almost the same thing as inertia. And that is why the Newton's first law of motion is also regarded as the law of inertia. So when you say Newton's first law of motion, you can also call law of inertia. Don't forget, we said inertia is the tendencies or resistance of an object to change its motion. That if it is at rest, the object will wish to remain at rest. If it is on motion, it will wish to remain on motion, as shown on the screen. Don't forget, this Newton's first law of motion and the law of inertia is the fundamental in classical mechanics physics. We show the groundwork to understand the behavior of an object under the influence of force, and it is also very important in physics and in engineering. This is a convenient point to stop for today, and we can now say that we have thoroughly looked at Newton's first law of motion, examples of Newton's first law of motion, and how Newton's first law of motion is being applied to various objects. In our next video, our next topic will be on momentum. And before then, as I always say, if you are just joining us, please don't forget to like, share, and subscribe. So when I upload a new video like this, you'll be able to get the notification in time. Thank you.